So I'm back. I'm doing more game dev stuff. Yesterday I was working on an updated master material. Today we're gonna continue that. What the fuck is this? Yeah. All right. It opened this up without my project attached to it. Let's just go ahead and open that right back up. All right. So yeah, basically we want to I had the master material. It looks okay. It looks pretty good, actually, I think. But there's a lot of parameters on it, and I'm not sure I needed them all. And also, I thought, hey, instead of just guessing what like a temperature maps look like, let's get some actual temperature maps of the Earth and try to kind of base our algorithm to generate things that look like that. And I want to do the same thing for moisture maps today. And that's pretty much it. So we're going to be working on a new Planet Master material. I really want to get it trimmed down to only the parameters that we need, um, without a bunch of redundant stuff or weird multiplications and things like that. And I want to base everything, or at least everything in this iteration, off of real world appearances of things. So we can demonstrate what I'm talking about here. So let's go to our demo level. All right, so this is our current material. We have a moisture map and then a ground gradient. Like we have a moisture gradient, a ground gradient. We have a moisture map and a temperature map, and we use those to generate this. I haven't done any work on the water shader. It's just a placeholder. And the atmosphere bubble here is another kind of work in progress that is for a little bit better depth fog when you're within the atmosphere or close to it. So like quick example of that. If I go down to the planet here, you'll be able to see. So like we get closer, it starts fading out, and then once we get down on the surface, we get like this nice distance fade, and it's really apparent when you start looking at like mountain ranges from a distance, right? From like surface level. We also want to incorporate the same like normal map blending that we're doing here to create like cliff faces. Right now, I just have them set to gray as a placeholder, but you could put like a rocky material or something like that in there. Um, so with that said, let's get right into it. Mesh planet. All right, so yesterday I was working on the temperature map. We should be able to see this, hopefully, if it's not broken. What the fuck? Where's my output? Oh, right, I was trying something out. Okay, so yeah, here's our temp gradient. All right, and that is our temperature is too low for this to be terrifically useful. What has happened to my world height offset? What the fuck? Well, I thought that we had everything we needed here. The fuck? It seems like we may have lost some progress, so I have to figure out what got broken here. A little annoying. Oh, you know what? I know what it is. Point. I think I might know what it is. Our mesh is too shitty. So yeah, that's right. We need a better preview mesh here. I remember this atmosphere bubble. We have a higher res sphere that I've used for atmosphere bubbles in the past. There we go. And now in our preview, we can select that. There we go. That's more like it. Okay. Yeah, that's much more like it. So, right. So, what we want is a temperature map that fades to colder at higher elevations and also fades to colder at higher and lower latitudes. And that's what we've got here. We can go set our settings back to what they were. Intensity 0.5. This is probably too high. 0.2. Go. 5. Probably fine there. Elevation fall off is too low. All right, there we go. Now we're back. So you can see that our mountain peaks get colder, right? As do our poles. And we have this kind of heat band in the middle, and especially over our continents. And this is what we did yesterday. And the fun part is that. Oh, yep, and that makes total sense. And the fun part is that this much is already kind of sort of good enough to get some interesting like planet variants, right? But we can do better. We need the moisture map next. So we're going to put this over here. And we're going to start thinking about what we need for a moisture map. And I think the best way to do that. And I think the best way to do that. Oh god, it's oh no, it's infinite. Okay, I stopped it. um, so the best way to do that is going to be to look at a real world example. So let's take a look at moisture map planet Earth. And let's take a look at how that patterns out because like we may not have to simulate this. We may be able to kind of take a look at what it looks like in reality and figure out a way to kind of mimic it, which is what we did with the temperature noise. Like, we're not simulating that. We're not simulating, like, wind currents or anything like that. This is fucking awful to use. Can I just open up the fucking image, please? We want to see what patterns this follows, right? So we have like a horizontally banded distribution with some curl. So like a pattern like this is actually not too hard to create. It's very similar to our temperature noise actually. It's almost identical. It's just that let's take a look at elevation contribution here. So elevation is drier at high elevations. But I think we can kind of discount that. So if we're doing it like that, then what we basically need is two more of these. So let's go ahead and start in a, so like we have this whole segment doing the temperature map calculations. Let's go ahead and start a new one for moisture. So we need a texture object. Parameter. We'll call this moisture curl noise. Stop that. There we go. And then we're going to need moisture noise. Oops. Great. And what I've been doing with these is using these double vector parameters to control them. So moisture curl offset XYZ, moisture curl scale XYZ. All right, and then we have our relative deal here. Sorry, just looking. It's here. So we add our offset, then multiply by our scale. So this plus multiply beautiful. Now moisture curl noise. This is going to be one of our volumetric curl noises that we um these don't come with Unreal. I bought these as a pack for like $5 on the marketplace, and it's been like a super great investment. So like highly recommended. If you don't use this, you can use the noise nodes to do the same thing, but it's way more computationally expensive to use these than it is to sample a texture. So um, these are good if you want to get like a really high precision at low scales, but if you're just carving out like macro features, it's way more efficient and performant to use a texture sample of a volume noise than it is to try to do the whole thing with, because you're gonna need one, two, three, four. Then we'll have an elevation variance noise. That's five. Yeah, so like it's rough. Like you have at least five noise nodes, probably would need even more than that, most likely, because to construct this moisture noise, we may need more noises. So replacing this with texture samples is a big performance improvement. Let's start previewing this node. Oh, right. Texture, that's the texture object. That's not what we want. We want this. Curl. And then we can start previewing this up. All right, so we have some curl noise here. So this noise is good for pushing things around in like swirly, kind of fluid-like patterns. You generally run this as a distortion, which means that we take the output of this noise and then modify it by some factor and apply it to the UV coordinates of another noise. And we'll go through how to do that in just a second. It's not super hard, but it is super powerful. It's probably like one of the coolest things I've learned since I started doing this thing a year ago was how to do like distortion. Okay, so the output of this is going to be between -1 and 1. We're going to take that output, multiply it by our intensity right here. Is that intensity really at 0.5? That's a lot. Oh no, I see. Another thing I often do, which is a little bit confusing um, when you're working like in the code or in the function itself, is it can be confusing when you're working inside here, but it's much nicer when you're working with the material instance itself or trying to randomize it. Is oftentimes you'll have things that need to have like really small values or really big values to have the proper effects. And maybe you don't want to have to set your value between 10 million and 30 million for it to be effective. Or maybe you don't want to have to set your value between 0.0001 and 0.0005 for it to be effective, right? Maybe you want the user or whoever's using the material to just be able to set the value between 0 and 1, for instance. So what I do then is I find a good baseline that I would say is like, what's the maximum then? Like, what is the maximum amount of this value that still looks good and isn't over the top? So you figure that out, and then you take the user's input and you multiply it by that, which is why we have this multiplied by 0.01 here and up here, because this needs to be a very small value, but I don't want to have to set 0.005 as the value of my intensity. I would rather my intensity be between 0 and 1. So I set a multiply node by 0.01 and set my baseline default value to 0.05, which means that my value is actually 0.005. But if I change this, it's going to be scaled based on this value, right? And so we're going to do the same thing down here. So we multiply our RBG output of our curl noise, which remember, that's between -1 and 1. All right, one sec. Also, I need to keep up with work. Hang on. Gotta check work laptop. One moment. All right, we're good. Um, and this becomes, so after we multiply it by our intensity, that becomes our distortion value. So next, we need a regular noise. And let's just use gradient as our default. We'll be able to change this. We'll be able to change this when we build our proceduralization harness. Okay, we got gradient. Our gradient noise texture. We need another texture sample. We plug this into the texture. All right, next. We're going to need the same two fields here. Temperature curl, temperature noise. All right, we basically need all the same things that we did for our temperature noise up there. Offset XYZ, we'll call this moisture noise offset XYZ variance range, and moisture noise scale XYZ intensity. All right, next we need to do this exact same thing here. We add the offset and multiply by the scale. And this hooks into our normalized world position. So we're basically dividing our world position by our radius. And in our case, a lot of times, like if you were just doing a material for a planet, you could just use the object radius. But because we are using a custom built mesh component, and each of the meshes themselves have their own radiuses, and the component is composed of a bunch of little grids of meshes, which we can see here. So each one of these is its own mesh, right? And that means that the radius of this guy is like this big, right? So we have to push in our radius from above, like from outside the material. We have to keep track of that externally. So in here, we just have it set to the size of the default display item here. All right, there we go. So now we have our noise, the gradient volume texture. We have the moisture noise offset, XYZ, variance range, moisture noise scale, XYZ intensity, um, multiply. Okay, we won't multiply that intensity yet. All right, so this right here is our baseline UV coordinate that would go into here, right? And if we preview this mode, we preview this node, we can see that what we basically have is some like horizontal, or it's not really horizontal since it's a sphere, but like z-axis squished noise is basically what this is, and that's coming from over here. If I turn this up, it gets squished more. And that's actually not too bad for a moisture map. So let's try that. And we can do, you can make these smaller too, or bigger. And there you go. So we've got some kind of wispy patterns in there, right? Like some horizontally, like almost like gas giant-esque patterns. Okay, great. So this is what it looks like undistorted. But we have our distortion factor that we calculated up here. So because this is centered around 0, it's negative 1 to 1. We can just add it. And you see that there's like some twisty turviness in there now, right? It's getting some turbulence. And we can turn that turbulence up. Or we can turn it off. Let's leave it at 0.5, but I think that we can go to 5. 2.5. All right. 2. And now we can just play around with these values and figure out what looks good, right? We can also try different curl noise. So those are some like nice swirly looking kind of air currents, right? Um, the part that I'm not sure about, I need to construct a mask for these. So like this is our base moisture map. Like this at its simplest, we could take copy of this, right? put it over here. Rename it. Connect one of these here. And I think what we may need is like one more layer of curl noise. We should want like some big changes and some little changes. Hmm. See, like to me, that doesn't feel too bad. Should we? I wonder if we should multiply it with the temperature map, or what we need is to decrease moisture when it's hotter, maybe. Where did it go? There it is. All right, so now we want to start blending them together and testing things out. So to start with, we're just going to do with three colors. Brown, green. Now I'm gonna need my gradients. Okay, so sample texture sample. All right, so first of all, this goes here. This goes here. This goes here. This goes here. With uh, uh, which one am I previewing? Alright, stop. I think we got some foliage. So then we have, okay, so we have the output here. We need to multiply that. By this. And then all right, now we're talking. That's pretty cool. Oh, yes. I think we're really getting somewhere with this. Obviously, like all the material shading parameters are wrong. You would want like, that's funny. It's a shiny planet. I mean, this is cool because we could make maps for this stuff too, right? Procedurally generate all this shit. Let's see. Fuck. Hang on. Having the little test height map on here is really nice for editing the material. All right. This might be useful. All right. I'm just thinking about all this. All right. So we do this, right? We multiply this with the intensity. Sorry, I was watching the movie on TV for a second. Let's see. So, yeah, I mean, this is good. The moisture map turned out to be pretty easy comparatively. We should probably run like a 1.2, 3, 4, 5, 6, 0.7, 0.8, 0.9, 1. All right. This is actually looking pretty good, I think. Looking pretty good. So we still need some other things like where's our height? Uh we have a Y input. So we need elevation noise too before it goes into these. And then we're done, I think. Well, not exactly. We need a multiplier. Could it be just a straight up add? All right, so we can sort of control sea level with this, but we need a way to bring the everything else back into bound. So what I'm talking about is like if this came in as a 1, right, and I'm adding zero point 0.3 to everything. So I need a way to like And smooth step this one. All right, so I think we're pretty close here. It still needs. All right, let's finish up the moisture map that we were working on. Get it cleaned up. All right. Do a little bit of housekeeping. What is this? Temperature. All right, and what's this guy? Okay. Boom. Boom. There we go. Awesome. Uh, all right, so we need one more texture sample. And we'll call this, let's see. We just want to use something that should be very apparent. So we'll use this. And it's going to get the exact same input as this. And it is you and you with this. Swippity swap these. All right, so now I need this to be on like a material. Um, so unfortunately, that means we got to go mess with this guy. All right, so we want all of this. So if this one's going to be mesh planet. All right, so let's go back to our material. Mesh planet. Okay. This guy. All right, it's just radius. It's height variance scale. All right, well, some of the scales are definitely off. But we do have the cliffside variance. So we're gonna need another gradient for that, I think. It's way, 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 way too small or something. Minute radius. What did I? Radius, high variance scale. Oh, that seems right. Are we too low or too high? What's going on? What the fuck? Nothing's wrong with the elevation. What the fuck? I'm gonna have to debug this more. It's just needs a little bit of TLC. What the fuck is going on? Oh. Oh, 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 oh. What? Not sure that's how we want to be controlling that, but like we got to figure out what's wrong with this first. How did I do that in the other one? Hang on. All right. So let's save that. See if that helps. Why don't we do it like this actually? We don't activate it at all. We'll go in here and we'll set it. This is back and I forgot if it, oh, it was like ray trace shadows. That's it. So we can fix that very easily. Boom. Perfect. Okay. I had that flickering on my mesh for like months, and before I figured out how to just turn that off and it fixed it. I didn't like try to fix it. I just wasn't worried about it at the time, but it took a while. Why am I at the top of the elevation the whole time? Relative elevation. Well, now it's not having an effect at all. Oh, you know what? We have to turn this off as well. Well, now I'm a little confused because to me, this seems right. Height is left to right. Temperature is top to bottom. All right, so this is what we want. We just have to figure out how to get it to work on the planet. Hello? Hello? All right, so why? So it's like this part's working fine. That part is all white. I think I'm just gonna have to sit and stare at this for a bit. Gonna go on music and turn my movie up. Alright, I think I poked at it enough to get it working most of the way. We still gotta get this parameterized properly. But, like, so all of these are good. Some of them need to be removed. The coastline effect that has is actually kind of nice. Cool. It's starting to look really good, I think. We can also probably get more quality out of this Voronoi. Where did I use it? Remap, add, right here. Maximum octaves on it. Gets his variance down to a smaller level. Why is this so small? Alright, we're gonna have to come back to this. This needs like tuning. Pretty nice. Kind of like that. That's so cool. Yeah. Getting somewhere now. Um, 0.2, 0.3, 0.4. I think that 0.2 looks quite good. I mean, it's starting to look pretty good, I think. Fuck? No, stop. Stop trying to auto update Visual Studio. I'll do that the next time I need you. Alright, next. The scale of this noise. Alright, I think this is pretty good progress for the moment. I'm gonna probably play some video games. Good progress for the day. So, like, I do think that this is probably the one we're going to use. The temperature maps and moisture maps just look much better on this. Pretty cool. Um, Not too much more work to do, I think. This is a pretty nice, concise set of parameters to control this with, too. There'll be a few more texture samples because we don't have our gradients exposed. Um, this stuff needs to be parameterized in the right ranges. Like, I shouldn't have to put like 0.03 here. 0.04, 2, 0.025, 275. All right. Yep, I'm gonna swap it over, play some video games for a bit. So, file save all, save all. Over the course of the weekend, I'm gonna get this polished up and get everything hooked back up into a proceduralization. Maybe paint some gradients. We'll see. So yeah, later. Why do these overlap like this? It's dumb.